Yep. All right. Hi, Aaron. We're sorry you're not feeling well. I'll leave this with Miss Tammy. If anyone comes in to get your work today, this is what you'll need. You have to complete number 1 through 6. It's a review paper, and we call it vanilla because that's the color. So if you, eventually I'm going to grade it for half a test grade. You can collaborate with people on it. That brings us to a new mod. So everyone put vanilla away. Make sure you don't lose it. I've had that happen to students. They get 3/4 away of these massive review exercises and they lose the whole thing and start over. So that's a tragedy. So don't be in such a spot. Mod number 8. If you would title your new section in your comp book, Mod 8, we're going to study work and energy. So it's kind of a little bit of a switch, I think. There's not like forces. There's going to be some forces involved. They never totally disappear. But I think this is sort of a new topic for us. And I'm sure you've seen it in your science past somewhere. Work and Energy, Mod 8. Title your new section that. In my thoughts, I was thinking, perhaps you were as well, kilogram meter per second squared. Does that look familiar? Is that fallen out of your thoughts? Put it back in if it is, if it has. Kilogram meters per second squared. What is that equal to? Does anyone recall what? Hannah? Yeah, it is a Newton. So kind of keep that on hold. It'll pop up when we least expect it in this mod. So keep that there for a little bit, just to review that. All right, let us define energy. I think you already know it, so take a note on it, fill in the blank. Energy is the ability to do blank. Don't say it out loud, but write it in your book. Energy is the ability to do blank. See if your science past can supply the answer to that blank, but keep it under wraps for right now. Energy is the ability to do blank. Fill in the word as you take the note. All right. Looking at your science past and looking at the definition or the chapter title, you probably realize that the word is work. If you didn't, fill it in now. Energy is defined as the ability to do work. It's kind of a strange definition when you have the word ability. It doesn't mean work necessarily was done, but the ability to do work. And we'll clarify that as we go along. So what's work? Work is force applied over a distance. Work is force applied over a distance. Mathematically, the math formula for it is work equals force parallel times distance. So this means force parallel, and x is distance. So that is one of the big equations for this mod. It's not the only one. So I start out with an equation right away. Well, usually when I give you an equation and define a new term like work, I say what's a unit. So looking how work is defined, what is the unit that would flush out if it's a force times a distance? Think of the unit for force, multiply it times the unit for distance, and what comes out? Hannah?
Newton meters?
Newton meters, but we are going to rename that. So that's way too long, Newton meters. Who ever heard of such a thing? We're going to call it a joule. When I was teaching this, one time I was pregnant, and my class tried to get me to name my daughter Jewel, spelled like that. But my husband wouldn't go for it, so she began to...
That's horrible.
Okay. Jewel, I've heard of that as a name.
Yeah, but not spelled like that. That's like Ladasha.
She grew up hating science. She grew up hating science, so it kind of worked out. All right, so Jewel is indicated with a capital J. Have you heard of it before in your science past? No? Some yes, some no. Okay. All right. Force parallel. Let's talk about that first. Why does the force have to be parallel? So let me show you a little picture. Does this show up over here in the video?
Yes.
Oh, wow. All right, suppose I have a wagon. Anyone have one of those little red ones? And so I'm pulling this wagon.
That's a really good looking
I have a small track.
stick figure.
All right, the person's pulling the wagon, and notice the force from the person's arm is not parallel to the motion that they want it to be in. So it turns out that the only part that will help, the only, what do you call it, not part, component, that's the word. The only component of the force that is going along in the direction of this arm, the only component that really will do any work is the part that's parallel to the motion, the distance that's going to be covered. So only this counts. So if this person wants to use the force of their arm more efficiently, he will stoop down and pull all in this direction. Of course, who wants to stoop down? You can walk along the sidewalk, all stoop down, pulling parallel. You'll get more efficiency from your arm, but your legs will be hurting. But anyway, this is the part. I'm just showing you that. That's why we say parallel. I think all our forces, are they all parallel in this mod? I think they are. But that's why, because that's the only part that really accomplishes any work. And the distance is pretty interesting. What if I pushed on this chalkboard for, what time are we out? We get out at 10:15, so I got 20 minutes. What if I pushed on the chalkboard for 20 minutes? I will probably start sweating at some point. I'd start aching, I'd start crying, but according to because you get tired, the work is defined as force times distance, and if the wall did not move, guess how much work I did in those 20 minutes?
Nothing.
0. So there must be a distance involved or there's no work accomplished. So keep that in mind. And so therefore I've discussed the parallel part, and now I've said there has to be a distance part or there is no work. Alright. I'm going to erase the top part and put up a problem. So we must do a problem. I'd like you to draw a bike of some sort. One of my worst drawings, but I never know where to put all the bars. I have to go study my bike.
Yeah, I can ride one again.
Yeah, alright. I'll bring it in and you can ride and I'll study how to draw it. There's no way I can get a person on it and it look decent. No pedals on this bike. Not terrible. Alright. Alright, you can go ahead and improve on that drawing, please. Alright, so drawing a bike, and the push from the person's legs is going to create a force. So there I said there wouldn't be any forces, but there are, but they're just parallel. So we're going to say this force is parallel. 15.1 newtons is the force of the person's legs created. It's going to take the bike 0.213 kilometers. And I want to know how much work is done. Find the work. Alright. So use the rectangularized equation here to find the work done when the force parallel and the distance are given. So calculators out, on and tapping away. Someone? What are you going to do with those two numbers, Brendan?
Multiple.
Right, force 15.1 times distance 0.213.
Do you have to change?
And we got like 3 sig figs going on. What?
Do you have to change 0.213?
Oh, you're right. Thank you. All right, thank you, Brendan. I forgot. I almost was going to do it wrong. We have to